We want to welcome all of you to our Decoding Talk just on quality installation. For the rest of the time, I'm going to try and just say QII because that is a tongue twister every time I have to say it. And we're going to talk about how things are changing for our next code cycle. We are recording this event. We record all of our events. We take the better of the four and we put it on our website, www.energycodace.com. And it will be there as a recording available for quite a long time. We have them some of them are 6 years old. We kind of have to update those, including our handouts. Our last Decoding Talk was on renewables, which is another pretty big topic for our next code cycle for residential construction. If you missed it, go check out the recording and grab the handout. There's some great information there. We are brought to you by Energy Code ACE. This program is funded by the California utility customers, that is you, so thank you, and administered by the private utilities under the auspices of the California Public Utilities Commission, and we always are in support to the California Energy Commission. My name is Gina Rodda, and I am the host of the Decoding Talk series, and I'm an energy consultant. That's pretty much what I do. I have had a variety of other roles as I've gotten here, but I decided about 12 years ago energy is what I really wanted to concentrate on. And I know it says here I'm starting my 9th code cycle. It's actually I'm starting my 10th and very involved in the next 11th and 12th code cycle. And Russ, you've been in this just a little bit longer than I have. Tell us a little bit about yourself.
Yep, just a little bit. My first job out of college in 1988 was doing Title 24 energy calculations, and I like to tell people I was using a computer that didn't even have a hard drive. We had to swap floppy disks back and forth, so that really ages me. But I also got into, I was working under Marshall Hunt, who was a mechanical engineer and has been in the industry for a very long time, and I got licensed as a mechanical engineer. Even though my degree was in environmental resources engineering, because I worked under Marshall, I was able to get a mechanical engineer license, and I'm licensed in 3 states. And HVAC design is definitely my passion, but it's always been wrapped around the energy code and trying to make homes energy efficient. And obviously, HVAC is a big part of that. And honestly, I have no idea how I became the QII expert here at CalCERTS.
It's because you like to put together that handbook. I think that's why.
It was, yeah. I had the handbook all ready to go, and so by default, it became my baby, I guess.
Russ and I have had the privilege of working with each other pretty closely over the last 10 years, I think, and it's always fun. The handbook, we're right here talking about the resources that we made available to you. In your last email, you had the opportunity to download our handouts, but let's say you forgot to look at that email or put it off. If you take your eyes and go to the left, you'll see Gina's favorite resources. Of course, the very first one is the Energy Code ACE website. The next one is the Online Resource Center for the Energy Commission. That's the best way to navigate their website. Of course, we have to give you CalCERTS' website. And to be fair, we're also including the other HERS provider that is doing work here in California, which is Cheers. And then the very last one is our handout. It will automatically open up a separate browser and then download automatically a zip file of all of these handouts we're about to talk to you about. And the very first one here is the QII handbook from CalCERTS. And one of the things I heard a lot in our registration questions is they wish there was some picture-heavy guide about what is QII going to entail out in the field. Russ, tell us a little bit about this handbook and your involvement.
Sure. It is basically the reference appendix section 3.5, RA 3.5, that covers all the protocols for QII. But if you've ever had to read through that, it is very, very just dense text, the entire thing. There's maybe 1 or 2 diagrams at the end of each section. But we felt that it really needed some diagrams and photos and things like that, and some clarification, extra explanation and things like that. And so that's basically what we did. Every page has 2 or 3 diagrams on it, and it's essentially the same exact language from RA 3.5. It's just had a lot of the repetition cut out of it and condensed down to a more readable format.
We want to tell you right now that the inspection procedures and how you meet QII are not changing much dramatically at all in how this is going to look and feel. And this handbook is still going to be a good handbook to get people prepared. But Russ, you guys do plan on coming out with a 2019 version, do you not?
Yes, we get questions almost on a daily basis that require us to draw up some sort of new diagram, new weird situations and things like that. So I have a big collection of diagrams and explanations that'll get added to this, and it'll probably almost double in size.
We're also providing to you, and this is more to help the designers on the call, a plan set that has QII integrated throughout it to help show you what needs to be included at design to be successful for QII. We're also providing a handout, and this is more thinking, okay, if people want a checklist, and this is really based on the inspection forms that are used, the CF2Rs and 3Rs, adding a lot of the pretty pictures to help make sense of it, but it can be used where you can rip it up and tear it up a bit and provide the checklist of each of the disciplines that have a play in this process. So that is something, another way of looking at it that can be shared. And then another tool to support the designers in the team. If we don't have QII dealt with in a good, solid way in the design set, it's going to limit the ability for that project to be successful. And there's going to be a lot about scheduling, who needs to be involved, who needs to understand what that's included in this note block. This note block was given to everyone in a Word format, so it is editable and can be integrated into drawing sets hopefully as easily as possible. And we're going to walk through all those requirements you see on there. Our goals for you today is how can that design document support a project in being successful? Russ, how important are the design documents to the QII inspection process?
Out on a job site, the plans really are the Bible for a project, and that's what everyone goes back and looks at. That's the official approved by the building department, and so the more you can have in the plans that support what you're trying to do as far as QII goes, the better off you're going to be.
Knowing when to contact and get that HERS rater on board and integrate them when possible. What is the best time for a HERS rater to be engaged in part of the design and/or construction practice, Russ?
Day one. The HERS rater is the one who is out there in the field telling people whether they passed or they failed. And it's kind of like if you could get a building inspector involved in your project early on, that's what it's like getting a HERS rater. They're the ones who've seen a lot of different problems. Chances are if you talk to a HERS rater, they probably have a project going on right now where QII is just not working for whatever reason, and they'd be more than happy to tell you how to avoid those problems.
One of the things that Russ and I hear a lot of people not wanting to engage the QII process is because they feel that the inspection processes are going to be a big impact to the construction practice, and that not everyone is going to understand what needs to happen for inspection. So we really want to work on and get across to everyone today being aware of the multiple inspections, what are they all about, how to be prepared for this process to be successful. We don't want anyone to be scared of the QII process. We want everyone to understand what's involved with the QII process to be successful. Here's our agenda for today. You'll notice we don't have a break on here, so hopefully you came fully prepared for us to go through our 2 hours together without a break. We have a lot of great things we want to go through with you today. Now that you know a little bit about Russ and I, we'd like to know a little bit about you. So we like to gauge and really figure out what we're saying and how much we're saying based on who is here. So if you could please let us know what role you serve so we can better serve you as being part of our session today. How well do you understand the QII requirements, just so we can get an understanding of what you know and what you're here to learn. And then we're going to check and make sure your typewriters are working, your typewriters, that aged me, your keyboards are working. And if you could please type in an answer to our what is the reason behind QII. And we had this issue earlier, Cassandra saying I can't choose when I have more than one thing. And you're exactly what happened earlier today. And you did exactly what we'd like to have happen. If you are either multiple roles or you don't see your role on there, please type into the webinar chat what it is that you do and who you are so that we can make sure to include you in terms of how we're going to talk about our topic. And yet again, Russ, we have a nice mix of people here in the room today. I honestly like seeing that we have a good contingency of energy consultants and HERS raters, because what I'm hoping we're going to be able to give you today is the ability and tools to be able to talk to people about this subject. Right, Russ?
Yes, definitely. I wish there was more architects and designers in this class like there was last time, but definitely good to get the energy consultants and building inspectors and plan checkers. Love to see them in the class as well.
We have some experts in the room today. With this is we have a lot more people who are feeling pretty good enough about the requirements of QII. So what I'm hoping you'll really get out of today is tools to help it go even smoother. And what is the reason behind QII? Verification improves installation quality. If installation isn't verified, install quality is typically poor. That is something that has been proven. To make sure insulation is applied properly so that it is as effective as possible. Excellent. And we'll go in a little bit more into the history of QII and how it came to be a code requirement. Let's get back to our presentation. So I always like to go into the why behind why we have our particular topic. Some people are like, oh, gosh, Gina, we don't want to know the why, but I just think it's so important. First of all, let's talk about what code year we're talking about. We are currently in the 2016 code cycle, which started for projects that pulled a permit as of January 1st of 2017, and will apply for projects that pull a permit up to December 31st of this year. Because starting January 1st of 2020, that's next year, projects that pull a permit through January 1st, 2020 through December 31st of 2023 will be subject to the 2019 code requirements, and there are some big changes for new residential construction, and we really are hoping people understand the impact of which day they go and pull their permit, or at least get a place in line and get it stamped as they are in the permit process. There are three major concepts to the Energy Code that must be understood when we talk about these topics. Mandatory measures are measures that are found to be cost-effective every time, everywhere, for all types of construction, residential, alterations, additions, all 16 climate zones. We don't typically see a lot of documentation in terms of forms for the mandatory measures because there are no choices. There's no choices to document. It is assumed that all designers understand those mandatory minimums and integrate them into their design. I find that sometimes a challenge. Then the prescriptive requirements are layered on top of our mandatory measures, and now these are cost effectiveness based on a particular climate zone, a particular type of construction, new construction versus an alteration. And we have the ability to use the performance approach using state-approved software to trade prescriptive measures, and you can trade them as far down as the mandatory minimum. But you also unlock extra credit items when you use the performance approach. And currently, QII is an extra credit performance option. You unlock the ability to use QII because you're doing a performance calculation, because you're choosing to use that extra credit energy savings towards another feature of the building. Russ, what's happening with the 2019 code cycle?
Well, the biggest change for QII is that it's going to become a prescriptive approach, which means it's on the house that you're being compared to. There's the standard house that has all the prescriptive measures on it, and that sets the target energy use. That has QII on it. So the proposed house, the house that you want to build, if you choose not to do QII, you've basically dug a big hole. You're already negative by a pretty big chunk, and we have some great slides that show just how big that hole is that you've just dug. So that still doesn't mean it's mandatory that you have to do it. It just means that it's harder to recover from not doing it, I guess is the best way to put it.
In fact, they put in a new item into our next code cycle in the performance method that if you put in a 5.5 kW battery, that would be an equal TDV energy to trading away QII. Now, there are other ways to do it, such as higher efficiency equipment, pretty amazing everything else that's above and better than code. But the easy backdoor is adding a battery to the PV system, which is also going to be prescriptively required in our next code cycle. So these are some big changes. QII is going to move from that performance extra credit to prescriptive baseline for new homes and for additions over 700 square feet. And that was something that definitely surprised both Russ and I. And Russ, talk to him about your concerns about additions.
Yeah, the problem with additions is there's so many different kinds of additions. There's so many ways to add conditioned space to a house. The easiest and most straightforward one is you just build a room. You just add a room onto the side of your house, and 3 of the walls are all brand new. The roof is new. The floor is new. That's easy. QII can be applied to that very easily. But most of the times what you see is people turning things like a basement into conditioned space, or a garage, or something like that, where the walls are existing, and maybe even some windows are existing, and then it just gets really strange. How do you apply QII? And you run into some really bizarre kind of construction practices in these older homes too.
So there are some exceptions that are put into play for the 2019 code cycle. These do not apply now. This does not apply to current code. But for our next code cycle, if you're converting existing construction to newly conditioned and it's over 700 square feet, there are exceptions associated with the window and door headers. We'll talk about how they will need to be insulated in any other application. And the air sealing shall not be required if the air barriers not being removed are replaced. So what do I mean by that, Russ? How would they be exempt from air sealing by converting an existing garage to conditioned space?
Well, in a new house, your walls are open, and so when you can see the studs and the back of the exterior siding, whatever that may be, you can run a bead of caulk along the bottom. You can caulk and seal along the bottom plate and things like that. But in an existing house that's been sheetrocked over, the only way to do that would be to remove that sheetrock, and that's just not cost effective in most cases. So they are giving an exception for that, but it's, there's a lot of good reasons why you may want to remove sheetrock other than just sealing. But if you don't remove the sheetrock, then you don't have to seal behind it.
So Brian is asking, a lot of large additions have a lot of alterations as well, and this is what we like to call an existing plus alteration. So I'm altering the existing home in addition to adding on the home. The QII requirements are only going to apply to the square footage associated as the addition and will not apply to the square footage of the home that was existing conditioned space, but it's being altered. So I hope that makes sense, Brian. And sometimes, when it's the same wall and one half of the wall was that existing garage and the other half now you're altering, there's a little bit of how best this is going to work in terms of out in the field, and that's going to be up to the HERS rater and the contractor to work out the best way to look at some of those features. Correct, Russ?
Yeah, and that would be the E plus A plus A, the existing plus addition plus alteration. And when you do that type of calculation, you designate each surface as either being existing, new, or altered. And so I guess what you're saying, Gina, and this is new to me, that only the new surfaces will be subject to QII.
Correct. They're saying it's only going to apply to the addition. And one thing to be aware of when we're converting unconditioned space to conditioned space for the first time, all of those surfaces in that space are considered new. They will never be considered altered because they're newly conditioned, and we have to look at how they meet these requirements. Who is the HERS rater and who put them in charge, Russ? Who are they? Who's hiring them?
Well, the Energy Commission sort of deputized HERS raters to be special inspectors, but it was with the input and approval of CALBO, California Building Officials, way back in the mid-90s, when they started adding energy features that required special testing and things like that. But the best way to think about a HERS rater is as a special inspector. That's a defined term in the code, in all codes. And building departments are used to working with special inspectors. There's all kinds of special inspectors. I met a guy not too long ago who was a disabled access special inspector. So that was his job, to go around. And basically a special inspector is somebody that the building department relies on when they don't have the in-house expertise, or in our case, some of the special equipment that's required to do the test. And so they've been sort of, I like to say, deputized to be special inspectors. They have to be trained and certified by a HERS provider, and there's a lot of QA requirements and conflict of interest requirements and things like that that go along with that certification.
Who's hiring the HERS rater?
Generally, for new construction, it will be the builder, or for an HVAC changeout or something like that, it'll be the contractor, the installing contractor. They have to be third party. They have to be independent from the people whose work they are inspecting. They can't be employed by them, and they can't have any other financial interest in the project. Now, something that came up was, well, what if they're also a consultant? What if they're the architect? What if they're the energy consultant? What if they're the mechanical engineer? And we discussed that at length with the Energy Commission a few code cycles ago, and basically the Energy Commission said, all right, if they're a consultant, that's fine. They can be the HERS rater. They're sort of on the same team, so to speak. The energy consultant is making the recommendations for the feature, and if they're also the HERS rater, they're the one going out into the field to make sure those features get properly installed. So that makes sense. There are some potential conflicts of interest that need to be careful about, but for the most part, it works pretty well that way.
I haven't seen it really abused at all when it's the energy consultant and the HERS rater. I kind of think it's a nice mix. And that's me being an energy consultant and not a HERS rater, saying that out loud. We asked you questions during registration. Thank you so much for answering it and made sure that Russ and I were on the right page with you of how to use your time. Are you aware of the QI requirements of the next code cycle? Over 60% of you said no, I don't know what you're talking about, which really concerns me. What is your biggest challenge regarding HERS, QII? Getting the contractors to realize it has to be considered. We have to talk about it. This is something that they need to consider before they start construction. What are your top 3 wishes? What I was hearing from so many of you is about communication. Communication with the contractors and with the contractors and all the subs and the enforcement process behind QII. If you could wave your magic wand, many of you asked for an instructional how-to booklet, so it was quite exciting to go, there's one here already. Here's the CalCERTS QII handbook, which is such an amazing resource. So thank you. Let's get into the bulk of our decoding talk, which is our 4 challenges. And our 4 challenges that we're going to go over with you today is, first, we're really going to dive into what should be included in those design documents. So I'm hoping you energy consultants here in the room, plan checkers, I'm not sure if we saw plan checkers, I know we saw a building inspector. What is it we should be looking for? What should be there at a minimum to help support QII? Atypical scenarios, things that can make QII inspection a challenge. Then we're actually going to walk through the inspection process out in the field as well as we can with pictures in terms of project scheduling and that inspection process. And then Russ is going to walk us through a kickoff meeting that what we strongly suggest all projects do, get everyone at the table before any ground has been broken and really see how the project should be considered by the entire team. But let's start with design documents. So before we get into design documents, what is QII and why is it here?
Well, it was interesting. The Energy Commission, along with a few other people, I know Rick Chitwood was involved, did a big study, and they looked at a whole bunch of brand new houses that were just being built and just finished, and they did infrared thermography, they did all kinds of infiltration testing, I think they did tracer gas testing, and basically every single house they looked at, brand new house, the insulation was installed so poorly that it had a significant impact on the R value. In fact, it was so widespread that they basically just assumed that that's how it's going to be done, you know, in a normal house. They just figured industry practice is to do a really bad job that affects the R value. So what they did is in the compliance software, the U factor is automatically derated by 13% because they that's what they found. Excuse me, I'm losing my voice for a second. And so the software does that automatically. When you just say, okay, I'm going to build a house, I'm going to put this much insulation in the walls, the software behind the scenes derates that insulation because it's just so common to do a poor job. Well, of course, the manufacturers and the insulation contractors didn't like that, just assumed to be proven guilty, you know, without any evidence. or before the fact. And so what they did is they said, okay, fine, here's what we'll do. If you promise you'll put the insulation in really, really well, we'll give you full credit for it. But here's what we want. You're going to check a box in the software, and it's going to trigger QII, which is going to trigger multiple HERS verifications. So a third-party inspector is going to come out and look at the walls before the insulation goes in to make sure they're sealed properly. They're going to come out after the insulation is installed to make sure it's installed really well. And you're not going to have things happen like what you see in this picture here. That is an automatic fail.
Now, why would we use QII? Current code, we use QII because we might want to engage that extra credit, and it's a nice chunk, as Russ was just showing you. This 13.3% degradation is now back into our pocket, and we can use that TDV energy savings towards other building features, such as like this building maybe having a lot of glass facing certain orientations that are above and beyond what the prescriptive requirements are comparing you to. Next code cycle, it's part of that baseline, remember, for new homes and additions over 700 square feet. You can trade it away. Now it's not extra credit anymore. Now if you want flexibility, it's trading it away with something that's equal in TDV energy. And like I stated earlier, what the Energy Commission put in as an automatic, this is a trade across the board, would be a battery of 5.5 kW or greater. Now, QII, is this something that's unique to California? Are we having a special formula yet again here in California, Russ?
Actually, no, it's not unique and it's not new either. It's kind of interesting. I get a lot of insulation contractors saying, hey, this is above and beyond. I've never had to do this before. And the answer is, oh, yes, you have. This has been around for a long time. In fact, this is not something that California invented. This is manufacturers' specifications for how you're supposed to install insulation. The one that I hear the most is the cookie cutter test, where you take that cylinder and you put it down into the blown-in ceiling insulation, and you take a sample out and you weigh it to make sure you have proper density, pounds per square foot coverage, because if you don't, the insulation will settle. And I've had contractors say, I've never seen this before. I've been doing this for 20 years and I've never seen this test before. And it's been around for quite a while. If you look, this is a technical bulletin put out by the Insulation Manufacturers of America dated April 1997 that shows about the cookie cutter test. And if you look on any bag of blown-in insulation before they dump it into the hopper that mixes it up to blow it in, there's columns on there, and one of the columns is depth. Everybody knows about blown-in insulation depth in order to get the right R value, but there's another column that says pounds per square foot, and that's a manufacturer's requirement, and the only way to know that that's done correctly is to do the cookie cutter test.
I actually collect manufacturer instructions for insulation. It's a little nervous habit of mine. This is me just Googling and seeing what popped up automatically in terms of insulation manufacturer instructions. And if you read these read almost exactly like the QII inspection requirements by that HERS rater. So this is 100% supported by the insulation manufacturers because they want their product installed properly to meet that warranty and R value that's promised by that product. So this is not unique to California. So what happens, what does this look like in terms of compliance? So we took that building, that's that set of drawings that's part of the handout, and we modeled it and stuck it in Climate Zone 12 that represents many of the valley areas here in California. This particular, I picked the city of Stockton because I went to school there, and that was an amazing experience. Let me tell you, being a girl who grew up on the ocean, suddenly going to school in Stockton. And they decided that they really don't want to do the prescriptive high-performance wall. They really want to do a 2x6 standard construction wall with R19, nothing fancy. Well, that puts them at a minus 10% compliance margin. They are that far away from meeting minimum compliance. By pressing the simple button within the software, and this particular screenshot represents Energy Pro, clicking that little button suddenly makes this difference, a swing of 11.5 TDV energy in the positive direction, and now suddenly my building passes by 0.8%. We just really need to make sure that everyone on the team is aware that that button was pressed. I moved my building to Climate Zone 3, that is the Bay Area, and I'm at minus 12.3% because I don't want to do the high performance wall. Now when I click the QII button, my compliance swing is a lot more dramatic. I have a 7.2 TDV energy swing. Why is it so much more dramatic in a colder climate zone?
Yeah, it's interesting. So much of California, we're kind of brainwashed into thinking about cooling energy savings, but people need to realize that insulation in the walls and the floor and the ceiling are designed to stop conduction, and conduction is heat transferring through a solid object like a wall, and conduction is driven by delta T, the temperature difference between the inside and the outside of the house. And in most places, the cooling delta T is greater. The temperature difference is greater in the wintertime than it is in the summertime, and so that's why you'll get a higher impact of anything that affects insulation in a more heating-driven climate like San Francisco.
Now we're going to take our same exact project and we're going to run it in the 2019 software. So I did add a PV system because we do now have prescriptive requirements for PV systems for new buildings, for new residential buildings starting next year. But you'll notice that all of a sudden I'm at minus 19.7% with me just saying, but wait a minute, the only change I made to me not wanting to have this high performance wall, and I gave you PV, why am I still so far away from compliance? Well, if you click that button for QII, because remember, you're compared to a building that has it, here we see that 11.3 TDV energy swing here in climate zone 12. I'm still 8.4% away from compliance because there have been increased stringency requirements for high performance walls, high performance attics, window fenestration. There are other things that are in the mix that I can't just use the same design anymore and expect to meet the energy code. If I was just passing in current code, there needs to be a rethink of how that building is going to be designed. Here in my warmer climate zone, you'll see that the impact for doing QII is not as dramatic. And both Russ and I feel it could be because of these increased requirements for insulation such as high performance wall and U factor in windows. There's just not as much energy being lost that can be picked up by a QII process. It kind of leveled the playing field with certain climate zones. So I wanted to walk through where you see QII being indicated within the CF1R. This is the CF1R performance form. Russ, in your opinion and experience, because you see all these come through the CalCERTS registry, how many times do people use the performance method for new construction?
For new construction homes, about 99.999% of the time they use the performance as opposed to using the prescriptive approach for a new house.
So it is the most common approach, so this is why we're showing it to you here. You'll notice on the very first page, it's always going to give an indicator of, there's HERS measures. There are HERS measures here, be aware. I love the second page because there's always a summary, and it always starts right off with envelope, and here we see high quality insulation installation, parentheses, QII listed as that has been selected as a HERS measure for this project. So this summary is a really great place to really go through, make sure people are up to speed on what's included in the project. Later on in the forms, it then goes a building feature by building feature. Here we were in page 6. It's talking about just what's going on with the building envelope, and it lists all the HERS measures that could be associated with that building feature. And here we see the very first box is QII, and it says required. It's not requiring HERS verification for quality insulation of spray foam insulation or building envelope air leakage. Russ, what is the difference between QII and quality insulation of spray foam insulation?
Well, the spray-on polyurethane foam, or SPF as you'll see it, actually serves two purposes. For regular insulation, you've got something in there that stops conduction, but you also have to seal separately from the insulation. But when you use SPF, the insulation creates an air barrier, and it seals as well as provides the R value for insulation.
So I have to say we use that one quite a bit as we're having more clients use spray foam insulation, and it helps us to really use the product they specified versus a default value for the spray insulation. When we think about QII, we have to be aware of what design changes need to be thought of to be able to meet the QII inspection process. And that really, honestly, in my heart, must be shown in the design drawings. Don't expect out in the field the contractor to build something that you didn't give guidance to, because they have to build from the drawing set. That is their design documents. That is their legal document that they must follow. So we need to do more to help support them being successful. And we're going to go through some of the top few problem features. We're going to start with framed corners. What are the issues regarding our framed corners, Russ?
Well, the traditional way to frame a corner is to use 3 studs like you see in the diagram here. And the 2 studs in the back are staggered from each other to create this little edge so that they can nail the sheetrock to it. And what that does is it creates this void back here where the pink color is, and that has to get pre-insulated, because once the siding goes on this house, you can't get to that anymore, and QII specifically requires that those be filled in.
So there are different ways we can think about those corners, aren't there?
Yeah, there's another way to frame it that doesn't take any more wood, it doesn't take any more nails, it just requires a little bit of sort of new technique out in the field for the framers. And what they do is they take this stud right here and they turn it sideways. As you can see in this diagram right here, it's turned sideways. And what that does is it prevents this inaccessible void. And so insulation can be tucked around there even after the siding goes on the outside of the building.
So it's not that sometimes we do want to think about different ways to construct the building to help alleviate some common issues that might happen with the QII process. Let's talk next about insulated headers. So I know that this is something that a lot of architects are like, what? I have to do something different with the headers? And this requirement is that you need to have at least R3 if it's 2x4 framing, R5 if it's anything other than that. So what are the challenges, and why do we have insulated header requirements, Russ?
Sure. One of the big things that the way we're trying to improve homes is to prevent the thermal bridging, which is basically having wood pass all the way through the walls, because wood's not a very good insulator compared to insulation. And anything you can do to sort of stop that short-circuiting of the heat to pass right through the wood is an improvement. Most of the projects we see, they use a rigid external insulation with like a one-coat stucco, and so that basically satisfies the requirement, because you can see right here the thermal bridging is stopped. But in those few houses where they've decided not to use any kind of rigid exterior insulation, that wood would pass all the way through, so we need to stop that by putting in a thermal bridging. And the reason this big header is there is because if you look at a typical wall, you've got studs every 16 inches on center. Those studs are designed to support a certain amount of weight of the roof pressing down on the top of that wall. And if you take out some of those studs to put in a window or door, you need a way to transfer that weight down on either side of the window or door. And that's basically done by putting in a big beam over the top. And so the more wood you have, the more thermal bridging you have. And so anything you can do to stop the heat from passing through that piece of wood is going to help a lot. And so QII requires that this be on the interior side of the house, mainly for inspection purposes. It would work just as well on the exterior side of the header, but it needs to be on the inside so that we can see it, so that it can be inspected.
Now my concern, here we have a detail, and this is in that plan set we gave all of you. Here they're using R4 as that exterior insulation, and this is a 2x6 wall. Because we're using R4 and we need at least R5, we do need to think about some additional insulation for that header, correct, Russ?
Yes. If they had been using R5 on the outside, they wouldn't have to do that, but then you'd have to do it for that entire wall in order to meet that requirement.
And Nick is asking, is this pretty much a mandatory requirement for QII?
It is a requirement for QII, yes. There were some statements in the 2016 residential compliance manual in the QII section that were accidentally left over from 2013 that implied that if you had a full width header that was authorized by the structural engineer or something like that, that you did not need to do insulated headers, but that was not supposed to be there. And if you read the QII protocols, they do specifically say that you have to have an insulated header.
And that's why we feel this needs to be supported in the design drawings, because it should be thought at as we're figuring out the framing and the materials and how the building is going to be built. It shouldn't be an issue that's suddenly discovered out in the field. Knee walls and skylight shafts. These are definitely something we have to think about differently also because of QII.
Yes, this is a fairly new thing. I know they didn't do it in the 2008 code, and that is requiring an air barrier on both sides. So here you see a skylight wall that's pretty much a vertical surface, and when you have a vertical surface, if you don't have this air barrier on one side, what happens is the air will come in and either rise or fall depending on what the temperature difference is, and actually create a little thermal siphon right through that insulation and greatly reduce its R value. And so the only way to really stop that is to put an air barrier on the attic side of that surface. So knee walls, skylight shafts are essentially knee walls. The other problem that typically happens, as you'll see in this detail down here, is they forget to put a block on the top right here too. A lot of times this gets left open. They'll just put the sheetrock or the air barrier on one side, and the air can move into the insulation and greatly reduce its R factor, R value. And so this is a nice diagram showing that you basically have six-sided contact with the insulation, and this will do a really good job stopping the heat transfer.
Let's move on to our next most common challenge, and that's scheduling. When does the HERS rater need to be engaged? When people think HERS measures, I have to say most of my clients are like, oh, that's all the HVAC stuff. And so they only think about having that HERS rater out there when they've installed the HVAC equipment. Is that going to allow a project to be successful with QII, Russ?
No, the QII is by far the number one highest fail rate of any HERS inspection. QII is head and shoulders above all the others, and it's primarily because of the lack of coordination and the lack of involvement early in the design process. The architect needs to be very aware of how they define the air barrier of the house and make sure that it's aligned where you have different walls coming together. You can't have one wall have the air barrier on the outside and one wall have the air barrier on the inside and think they're going to line up and then try to figure out how to seal that gap and things like that. The other thing is designing the house in such a way that you can get sheetrock or some other kind of air barrier on both sides of those walls. There's a lot of places where it's really, really difficult to get something on the back side of a wall if it's isolated. We have a really good diagram of that round part of the building is a big problem, and those need to be thought out as early as possible.
So we strongly recommend that there be guidance integrated into the design set about when the HERS rater should be engaged and the inspection schedule. Anything you want to add to that? I mean, this HERS rater has a lot of work cut out for them, especially for a construction team that's never experienced QII before.
Yes, HERS raters have become trainers and educators. Is probably their second biggest part of their job is training people in the field. It's unfortunate that the trades aren't trained better by their associations or their suppliers or whoever, and the training happens out in the field, and a lot of times that's too late, and people just aren't happy about it.
So we want to make sure that you have the tools available to get that communication into the design set, hence why we gave you that note block in a Word document. We do expect you to go through this, see what's applicable to your particular project. I know we didn't have many architects on the call this afternoon, but hoping energy consultants, HERS raters can help share this messaging to others out there about how to be successful. Let's do a check your understanding on the importance of including QII in that design set, and we have a few questions for you. Why should a HERS rater be engaged early in the project? So this is pull out your keyboard and type in an answer. Why would a project use QII? And these are all in your opinion. And then my last question, is guidance on the design documents for QII required by the Energy Commission? Russ, in your experience, are we starting to get people to engage the HERS raters earlier? Is the market starting to be cognizant of this?
We're starting to see it, yes. When we have HERS raters who work for production builders, they'll learn the lesson from the first one or two subdivisions, and they'll say, you know what, we've got another subdivision starting. Let's get this HERS rater out here and have him sit in on some of our coordination meetings.
So I'm loving some of the answers to our questions here. Why should a HERS rater be engaged early? I kind of like this one because you'll almost definitely fail, and it's helpful to know early on that you'll fail. Don't have that attitude. Really, honestly, getting this and understanding it early is going to enable us to be successful. I don't really feel myself personally that QII is the worst thing that can happen to a project. As a potential homeowner, I sure as heck want it on my house, but it needs to be coordinated, and everyone needs to know what they're doing. So excellent. Why should a project use QII? I like the answer, just a simple one, just to get compliance. To meet the standard design, that's going to be in place starting next year. This year, it's still an extra credit measure. Is guidance on the design documents required for QII by the Energy Commission, Russ?
It's actually not required, but it is definitely highly recommended.
So I honestly think we should make that a requirement, but we can't make the rules. It is highly encouraged. That is the #1 tool in getting people all on the same page and understanding this project is a QII project, and there are some things that have to be done special about this job. Let's go back to our presentation and move on to atypical building features. And these are features that can be challenging depending upon how they're built and how they're coordinated. And we're going to talk about drop ceilings, double and staggered stud walls, difficult building features, and then we're going to talk a little bit about multifamily. So let's dive right into drop ceilings. What are those, Russ, and what do we need to consider for a QII project?
Well, when you get up in the attic, ideally, if you were going to insulate a ceiling, you would want that ceiling to be flat, the entire ceiling, just all one single flat level, and then you could just blow in insulation and everything would work great. But for architectural reasons, we have rooms that have lower ceilings than others, and so you have these drops ceilings, and if they're narrow enough, you can make them flat by putting in a hard cover and covering it up. So you'll see in the diagram here, this hard cover right here is holding up the insulation. If we didn't have it, the insulation would drop down inside here, and then we have extra surface area that needs to be insulated that adds to the conduction and heat transfer in the attic. So we need to put hard covers wherever we can. The problem is that there's no specific definition for this distance from here to here as to when you have to put a hard cover. You know, a piece of sheetrock will only span a couple feet unless you brace it up with some kind of framing or something like that. And so there's a lot of situations where you may have a much wider gap like this that has you know, a lower ceiling. And so what you see here is if it's too wide to span across with a hard cover, then what you have to do is this little wall here, which would normally be below the insulation, now becomes an exterior wall. And so you have to have sheetrock or an air barrier on both sides of it. Same thing with this one over here. And then, of course, if there's 4 sides to this drop, you've got to go all the way around to do that. So that's a lot of extra work sealing that up. The insulation now falls down to this. So this is the exterior surface of the building right here. And then if this is blown in insulation, which it typically is, you need some sort of a dam here to keep it from falling over and dropping down into there. So that's quite a bit of extra work to do, but it just depends on what this distance is across here as to whether you could cover it up or not.
I want to point out this one bullet point. Sheetrock edges still need to be sealed. So we're used to just cutting that sheetrock and just slapping it in place. What do you mean by that?
So that would be this top edge here. And if you ever looked closely at sheetrock after you've cut it, it's basically like plaster of Paris that's sandwiched in between two pieces of paper. And if you leave that plaster of Paris edge, it's very brittle, very the moisture gets in it and it starts to sort of decompose and it starts to fall apart, and then eventually all you have left is just two pieces of paper just kind of flopping around there. So yeah, just put a piece of tape over that to keep it from just disintegrating over time.
There's other things you can use as an air barrier, such as plywood, such as rigid insulation. We're not saying sheetrock is the only air barrier method, but there are considerations from every single one of those, whether it be cost or simplicity and or sealing that sheetrock edge. So here we have a drop ceiling, and there's a lot of little nooks here that potentially could be missed. And I really like your way of looking at how do we find all of these nooks and crannies, Russ. What is your advice?
The best way to do it is to just get up in the attic and stand there before the sheetrock goes on, before the insulation goes in, obviously, and just kind of scan around and just try to imagine this perfectly flat surface, if possible. Imagine that you're going to fill it up with water. You're going to have about 6 or 8 inches of water. And where is that water going to leak out? Insulation, blown-in insulation, even though it holds together fairly well, will over time start to find little holes and drop down into little holes. So this photo here is a good example. If you didn't have these blocks here, that insulation would just fall right down into this void. And so you need to block those off somehow.
And here we have an example of a project that's done this pretty well.
Yeah, this looks great. It's always nice to see a picture of something done well. For every picture I have of something done well, I have about 1,000 pictures of something done really, really bad. But this is a kind of a void, a triangle-shaped void in the wall that's going to be sheetrocked over. And if I had to guess, I would say there's a fireplace down at the bottom of this. And this looks like a fireplace flue going up through here into the attic. And so they did a nice job cutting a triangle piece of OSB and placing it over and attaching it to the framing. But what I really like about this picture is this white bead of caulking right along here. If you take OSB and just set it on top of a 2x4, it does not make a very smooth, even seam. There's a lot of little gaps and things where air can pass through there. So you really need to not just screw it down or nail it down, but you need to run a bead of caulk, and that's required by QII.
Let's take a look at all the penetrations that can happen with my ceiling air barrier. Walk us through these.
Yeah, if you walk through a house, just walk through a typical house and go into every room and look up at the ceiling, and you'll realize just how many penetrations there are. There's exhaust fans, electrical boxes, fire sprinklers are becoming a requirement throughout most of the state, register boots, you've got ceiling fans, you've got smoke detectors. All those penetrations, if you take the cover off and look, the sheetrock hole is bigger than whatever is coming through it, like the junction box, for example, and that's just a prime place for air to escape through. And if the air is going up through there and passing up through the ceiling insulation, that insulation is not doing any good. You know, a lot of people think, oh, insulation must filter out the heat, but it doesn't. If the air is passing through it, it comes out the same temperature on the other side. So these are all places, and one of the biggest problems that we run into is who's going to do this. If this is not clearly spelled out on the plans or in the contracts with the trades, everyone's going to point their fingers and go, oh, no, the electrician was supposed to do that, or the HVAC guy was supposed to do that, or the insulation people or the sheetrocker was supposed to do that. So it needs to be spelled out so that no one's forgetting to do these things, because they all need to be sealed. Now the one thing where health and safety always trumps energy savings is with fire sprinklers. There was a while there where if you couldn't seal around the actual sprinkler itself to the sheetrock, what was recommended was that you build a sheetrock box over the top of this. And it turns out that was not such a great idea either, because a lot of these fire sprinklers, in order to activate the fire sprinkler, they actually need air to pass through them and past them. And so that's not good for our nice airtight building, but it is how those fire sprinklers work.
So now let's talk a little bit about double and staggered walls. Doubled walls, I find a lot of times are there because of a certain look or feature of the building. Staggered walls we're starting to see a lot more often. I know I have my clients who are starting to use staggered wall more often so that they can have the continuous insulation on the inside of the wall versus the exterior of the wall. What should we just be prepared for when we're thinking about QII for these building features?
Yeah, that wall, so these staggered walls like this one here, what they're doing is they're using a 2x6 or a 2x8 bottom and top plate, but 2x4 studs. And so that allows you to push one to the back and then pull one to the front. And remember I talked about the thermal bridging. What this does is it prevents thermal bridging. So there's no place where there's wood passing all the way through from the outside all the way through to the sheetrock inside. And that's a great concept. It's a great idea. The challenge is completely filling this wall with insulation. If you use bats, you have to have 2 layers of bats, one along the outside and then one along the inside. And so here's an exterior stud, and so that has insulation between the exterior studs, but then another layer of insulation has to come through. And when that piece of insulation is pressed back into that gap or that space there, it needs to be fully in contact with the one behind it, so there can't be any gaps or any voids in that wall. That can be a real challenge. Another way to do this that I see that works really well is the blown-in wall insulation, where they nail a fabric over the front of all these studs, and then they just poke a hole in that fabric and fill it up with a loose fill fiberglass, and that seems to work really well too. But you can certainly do it with bats if you're careful.
I think this picture is just a beautiful picture of how it can be done well. Thank you to Bright Green Strategies to give us pictures of good install. So here we have a bunch of bump outs, which I like to call double walls. And there's things we have to consider about how to meet the QII requirements with these building features, right, Russ?
Yes, these are very common, especially in tract homes where they're trying to create a little variety between the front elevations of all these houses that are right next to each other. And so they'll do these little architectural, we call them bump outs or pop outs, and it's just basically to frame out a window to give it a little more style as opposed to just a flat wall that the window is in. And the challenge is insulating those, and because these are vertical walls, they have to have an air barrier on both sides. And so imagine this being framed out with all these studs like this. How are you going to get that piece of sheetrock or air barrier to, who's going to nail it back in there and who's going to get it to fit? That can be a real challenge. So you basically have a choice when you have things like this. This top illustration is the recommended choice, because not only is it probably the easier one to do, but it has the least amount of surface area. So, you know, UA delta T is conduction, and so the less your area is, the less conduction you will have. Now you could, if for some reason it was easier to come around the exterior part of the wall, that's fine too, but you have to remember you have to have this interior air barrier, and somebody's got to put that in there, and that can be a real challenge depending on how far apart this framing is. You know, you may not even be able to get your arm in there, or a hammer or a screwdriver to attach that sheetrock or whatever it is. And then finally, this is allowed as well, and that is just to fill the whole thing up with insulation. Obviously, it depends on how big it is and how much insulation it takes to do that. You could do it with bat if you needed to, but you have to remember there can be no voids, no gaps, no air spaces inside this entire pop out here from the bottom all the way up. You got to remember there's a third dimension coming out of your screen going up, and then there's probably an arch or something go over the top of the window as well.
Fun building features. I can see you can even imagine them in your head. And I know you referred to this particular picture already earlier on in this session. Give us your opinion about how QII is going to work for this building feature.
Yeah, this reminds me of a house that we actually had one time, and this one's actually a little bit easier. What we had was a curved stairwell in a square corner of a house. This is a round inside with a round outside too. So these two walls are parallel to each other, but we had a square corner with a curved wall in between. So you imagine this sort of semi-triangular shaped void, and that curved wall, because it's curved, because these walls are curved and they have to get the sheetrock to mold along that curve, it takes a lot more framing. So you'll notice these framing members are a lot closer together than a typical 16-inch wall, and that's so they can nail the sheetrock up to it and get it to curve. Well, that's just that much more framing you have to worry about getting your insulation to go inside that. So these two, I'm looking at this and saying that's probably 12 inches maybe from inside to outside. So that would probably be a good candidate for just filling the whole thing up with insulation. But in the one I was talking about, where the inside wall was curved and the outside wall was square, we had a big triangle, and what they ended up having to do was put sheetrock on the back side of the interior wall, the round wall. So they had the sheetrock on the inside and the outside of this curved wall, and it was just a nightmare to get it to work. Otherwise, they would have had to fill up like a 3-foot deep corner with insulation, and they just weren't able to do that. So yeah, these can be a real challenge. Also look down here in the lower left-hand corner. You see all this framing. How are they going to get a two-sided air barrier on this wall? That's going to be a real challenge.
What do you think about this one?
This one actually looks pretty good. So this looks like there is an 8-foot ceiling down here. The room that we're standing in where the picture was taken from is a much taller ceiling, and that creates this knee wall. So behind this wall is attic space, unconditioned space back in here. And so what they had to do is they had to put this air barrier on the back side of this knee wall before the insulation goes on. The one thing I really like about this is you see this expansive foam on here. It looks like they were a little sloppy right here. I might call that out and say, hey, you missed this spot, come back and redo that. But for the most part, it all looks pretty good. The other thing to notice is there's pipe here. Insulation has to go on both sides of that pipe. These little blocks here, I'm not sure why they're there. They're probably the ends of some framing members. You've got to get the insulation tucked around those so that there's no voids and no gaps. Once they sheetrock over this entire wall, it needs to be a nice solid mass of insulation with no gaps and no voids.
Since you like no gaps or no voids, what do you think of this one?
This one looks good, and what I really like about it is they actually took the time to cut the bats to the proper shape, as opposed to just cutting a piece of fiberglass and stuffing it in there to make it the shape of the space. You see this little triangle looks like it was nicely cut. This triangle looks like it was well cut. So somebody actually sat down and took their time and really measured this out and did a nice job on it. So this is a situation where you've got a vaulted ceiling in one room, say the living room, and then you've got a lower ceiling in the adjacent room, say the kitchen, and then it creates this triangle-shaped knee wall. Now, what I really hope, and I'm pretty confident is there because how well this insulation looks, is that there's some kind of air barrier on the back side of this.
And then this one is at a low-rise multifamily building, and this is the 3rd floor above grade, looking outside to inside.
Yep. Multifamily, because they're typically taller buildings, they have a lot of extra framing in them. Just look at all this wood that's conducting heat. Now this is an interior wall teeing into this wall that we're looking through, and this is that void I was talking about that gets created. If the siding were to be put on this building right now, that void would stay empty, and that would create a lot of thermal siphoning and air movement would happen through there. If you were to look at that building with an infrared camera, you would see that. That would show up as a bad spot. A lot of extra framing in here, so all these odd shaped, these narrow cavities here, the insulation needs to be cut and placed inside. You see here's another one over here. You can't just cram it in there. You've got to cut it and put it in there nice so that it maintains its true R value. Also, there's a junction box here, and that's through the exterior wall, so once the siding goes on, that's going to need to get sealed around.
And be aware, for the 2019 code, the QII becomes a prescriptive requirement not just for new single-family homes, but also for all new low-rise multifamily buildings and any additions to those buildings that exceed 700 square feet. And when we think about multifamily, there's a lot more to it. And in fact, I'm going to bring up this slide, Russ, so that you can walk through what are the different aspects of a multi-storied multifamily building that we need to think of when we think QII.
Yeah, the first thing obviously is the sheer size and complexity of multifamily buildings have a lot more opportunity for mistakes to be made. But the other thing is you've got multiple dwelling units. So you have dwelling units that are adjacent to each other, and those walls are not considered exterior walls. And so even though they may be insulated for sound purposes, those interior walls between dwelling units are not subject to QII. But the most important thing is to figure out where the heck is your air barrier, where is your boundary between conditioned and unconditioned space. And this diagram is a great example of somebody sitting down and figuring that out in advance. The other thing about multifamily is a lot of times you have these unconditioned corridors. Okay, in between here you've got stairwells, you could have garbage chutes, lots of ventilation shafts and things like that. Those all need to be sealed off. And this is just a great example of sort of thinking it out in advance.
I also love on a little bit lower from your arrow here, I'm going to take your arrow, Russ, and take it. Look at here where they're indicating this is unconditioned or open to the outside below this floor. And this, we have to consider an air barrier because not each floor is stacking up beautifully on top of each other.
So is that like a cantilevered, which
yeah.
I think we have a very good diagram.
Mm-hmm. So when you're doing multifamily, there are things to consider, just a lot more angles and layering on top of each other, where's conditioned, where's unconditioned, and where should that air barrier be really considered. We have a little video here that we just kind of play with in terms of what is it that if we were to take things apart, we're looking from the attic to a living room. Here's the chipboard, here's our framing, here's our insulation that maybe isn't installed to QII requirements.
Fix those gaps.
Fix those gaps. And here they are using rigid insulation as that air barrier product on the side of the attic for their all 6 sides. So there are many different ways we can think about doing that air barrier. Now that we've all talked about what are these atypical considerations, we have a check your understanding. So a couple questions for you. Should the contractor be aware of the QII requirements before they start building? In a multifamily building, is the wall between the dwelling unit and an unconditioned corridor subject to QII requirements? And then I'd like you to tell me in the last question, what should be considered for this building feature when considering that the project has to meet QII requirements? What would you suggest to be done for this particular building feature? You guys are answering very quickly this time round. Everyone is very awake for this check your understanding. Okay, you guys got the easy questions out of the way. It's time to think about what do you think, in your opinion, should be done to successfully get this building feature through QII. So Russ, everyone is answering, and this makes us so excited for our first question. Should the contractor be aware ahead of time? Yes. It's close to impossible to succeed unless the contractor is aware, and aware early. So I'm so glad that that really is resonating with all of you. And a multifamily building, the wall between the dwelling unit and the unconditioned corridor, that is going to be subject to the QII requirements because we have unconditioned on one side of the wall and we have conditioned on the other. This is a demising wall, so it's very similar to those attic knee walls, to the skylight walls. This is how we look at those walls for non-residential multifamily construction. How about our answers?
I threw a couple people off. Sorry, I think I threw a couple people off when I said between dwelling units is not subject to QII, but between a dwelling unit and an unconditioned corridor is.
That's a common misconception, though, Russ, and I think it's great that we were able to emphasize that fact. I'm going to let you go through the answers here. Do you have any favorite answers to our QII challenge feature?
Let's see. Yeah, air barriers. I really mentioned that. How to seal 6 sides is a good one. Cutting the bats to the proper size. These are narrow. You know, fiberglass bats come in standard sizes, and they don't come in whatever size this is, I'm sure. So they're going to have to trim those bats down. Yeah, all those answers look really good.
I really like the prelim walk with the HERS rater. Let's
Yeah.
really, before anyone does any more work, really think about how are we going to do this. And I actually think that should have happened at design. But hey, if we're going to have it happen here when we're out in the field, that works for me too. Okay, excellent, everyone. Let's go back and let's now walk through on-site what this inspection process looks and feels like. So, Russ, walk us through the different design and construction phases and what should be considered at that time when we have HERS QII verification.
Right. So at the design phase, there's a lot of times that especially in subdivisions and larger custom homes, they'll have what's called a kickoff meeting. So the architect will send out a preliminary set of plans and ask all the consultants and all the trades to make comments on how those can be improved. They used to be called value engineering meetings, and it was just a way to sort of re-engineer the project to save money and things like that. But now it's to engineer the project so that it's buildable, so that it meets code. The HERS rater really should be involved in that. The HERS rater is one of the most experienced people in terms of QII, as well as some of the other HVAC stuff as well. But getting them involved as early as possible to help identify some of the projects. And we have a great example of that later on. And then when the project goes in to get the building permit, you know, the CF1R is finalized, and that's where it says, you know, QII is going to be required, and that's where the HERS rater basically has the go-ahead to say, all right, start contacting people and making sure that they're all on board and they understand what's going to happen. As far as grading goes, you know, grading the site has nothing to do with QII, but that's sort of a dead period between getting the building permit and before they start framing, before they pour the slab and start framing. That's the best time for the HERS rater to start calling all the trades and saying, look, you know, you're responsible for sealing around the junction boxes. You're responsible for making sure there's hard covers over the drop ceilings. You're responsible for this. And that sounds like a superintendent's job, but you know, the superintendent is going to basically ask the HERS rater, how do I make this happen? And so that's a good time for that sort of coordination to occur. And then once the house is being framed, that's where it's really important that the air barrier, that they follow the plans and make sure that it's framed so that the air barrier is continuous throughout the entire building, that all hard covers and draft stops are installed the way they were planned. Then the next step is the rough-in. So they start doing things like the pre-insulation of those exterior channels, if those happen to be there, pre-insulating where tubs and showers are up against an exterior wall. That's a big one. We've got some good examples of that. Then the insulation starts going in. And, you know, we've talked a lot about the problems associated with not incorporating HERS QII into the design, the coordination issues and things like that. But really, probably the second biggest problem is just the quality of the work being done. If you're ever out on a job site and you watch insulation going in, some of those poor folks that have to put in the insulation. I did it one summer. I helped a guy build a house, and I insulated a house. And it is absolutely the most miserable job there is. And my theory is that every insulator on a job site, their goal in life is to no longer be an insulator. They want to move up in the totem pole.
It's the one sub-consultant out there that there's a high rate of turnover. So, and that can be challenging for the HERS rater who is trying to constantly educate the new people who showed up the next day.
Exactly, and you literally could have a different person every day doing the house, and that person needs to be trained every day. So somebody who knows what they're doing has to be out there. You know, usually the supervisors who work for the insulation contractors, the owners of the insulation contractors, they know what's expected. It's just getting it down to the people who are actually touching that insulation and sticking it in the walls. That's a really big challenge. Then drywall. Early on, hasn't been as big of a problem. I think most people are aware that the insulation needs to be inspected, but early on when we were first doing QII, I can't tell you, several times a week HERS raters would call me up and say, hey, I went out to inspect the insulation and they've already sheetrocked. What do I do? Well, the answer is you fail it. That is an automatic fail. If they didn't see the insulation and it gets covered up, it's a fail. And now their options are to either take off the sheetrock, which nobody's going to do, obviously, or rerun the calcs without QII in it. And as we showed early on, that's a big deficit. And when you're this late in the process, when you're sheetrocking the house, there's not a lot of options left that you can upgrade to improve energy efficiency in the house. So that's
as we talked, I think before we even went live, this is where that battery storage suddenly becomes something that is viable, because you can add it at any time throughout the construction practice, including at the very end. Rerun the calc showing that with that 5.5 kW battery, you still pass. But batteries aren't that cheap, and they're not getting cheaper depending upon who's manufacturing them at the time. So I think that every contractor out there should be cognizant of that and be aware of the cost associated of missing an inspection.
Yeah, in the current code, some of the things that we've seen people attempt, and occasionally it works and a lot of times it doesn't, is upgrading the condenser to a higher SEER and higher EAR condenser, upgrading the water heater. You know, obviously you can't replace the windows. The windows are already installed. You can blow in more insulation in the attic if you've got room for that. So there's a few things that can be done, but it's tough. It's really hard to do after the fact. And then of course at finish, that's when everything's pretty much done and inspected and people need to fill out their forms. So the CF2Rs need to be filled out by the installers. That's where they attest to the fact that they put in the right stuff and they did it well. And this is where they document all the brand and the R value and the depths and the densities and all that good stuff. And then the HERS rater certifies everything with the CF3R form. And then of course final inspection by the building department. We're doing a lot of training of building departments on how to use the HERS registry as a tool to keep track of all the forms. And there's something called the project status report. For every single project, you can open up a project status report and it will list out all the compliance documents that are required for that project, and it'll put a green dot or a red dot next to it telling you whether it's been completed or not. And so we're really pushing hard on building departments. In fact, I was at the Gabel conference all last week in San Diego telling building departments, do not final a project until you see all green dots, because that means all the 2Rs have been signed by the installers and all the 3Rs have been completed by the HERS rater.
Here's another matrix that we have. We included this particular matrix as the last page of the CalCERTS handbook. And I really like this because it really breaks down all the different subs of the project. And again, we're seeing the different phases of design and construction, but how many times some of these particular individuals need to be interacting with the QII process, right, Russ?
Yes, absolutely. If you look on the far left-hand column, we see all the people that are potentially involved, and this is just QII. You know, the energy consultant triggers QII, they recommend it, the builder says okay. You got the HERS rater, insulation installer, you got the framer, the drywall installer, and then a whole bunch of miscellaneous trades. The electrician, the plumber, the HVAC folks, they all have something to do with sealing and QII. Then across the top you have all the stages of construction from start to finish. And so what this matrix really does well, and keep in mind this is just QII. This is not everything else. This is just QII. At all the different stages where somebody needs to do something in order for QII to happen flawlessly. A big one here that you may not have seen in the past is in the design phase. This is that kickoff meeting I was talking about, and it's really good for all of these people to be in the same room, sitting around the table, looking at the plans and saying, oh, look at this. Boy, if you build it like this, you're going to have a really hard time getting a drywall air barrier on the back side of this wall. You may want to rethink that. You know, those types of things. Pointing out potential problems before they become problems. If you scan across, you see the HERS rater has a lot to do with QII. Obviously, there's forms that have to be filled out, multiple inspections. Then, of course, the insulation installer has a lot to do. But everybody, the framer has things to do. The miscellaneous trades have things they have to do. And it's a very involved process.
But doable if coordinated well and everyone's aware ahead of time. Now, when we talk about air barriers,
yep.
it's not impossible. Russ alluded to the fact that when we look at vertical versus horizontal surfaces, the air barrier is looked at differently. Walk us through this, Russ.
Sure. When you have a vertical surface like this, let's say it's cold outside this building and warm inside this building, and if you didn't have this interior air barrier on here, what happens is air will find its way, will migrate through here, and actually what happens is the air along this wall, because it's cold outside, will start to cool off. And when it cools off, it gets more dense and it sinks. So the air will start moving down this way, and when it gets to the bottom, it comes out. But what it's doing is it's pulling air in behind it. So now you've got conditioned air being pulled through the insulation and cooled off, and it creates a thermal siphon. And what that does is it really degrades the R value of this wall. And the best way to stop this is to put on this other air barrier so that it's in contact on all 6 sides. Now, if you flip this around and make it a knee wall so that the attic is on one side, it's the same exact thing. Now, on a horizontal surface, it's not quite as bad because you don't have that vertical surface that's allowing the air to move as it becomes more dense. So as the air gets more or less dense, it just kind of pools or puddles along here. You will occasionally get some of these little thermal siphons coming up through here, but it's not nearly as much. So it's just simply not cost effective to put another air barrier on top of a horizontal surface like this.
So let's start doing our inspection. So Russ, we're going to walk you through a couple of different scenarios. Here we are, we're looking at some walls, roofs, floors. We're looking at various penetrations to our exterior envelope. What are we looking for?
So this is one of the first inspections that a HERS rater does. Is they go out before the insulation is installed. Even though you see insulation in this picture up here, the idea is that they walk around. And what I tell HERS raters and how I train them is to imagine this house being pressurized by a blower door. You have a big fan that's pressurizing this house, and the air wants to escape. Where is that air going to escape? And then so walk around and seal all these penetrations. If there's unconditioned space on the other side of this 2x4 here, air is going to slip around these pipes. So you got to seal around there. You got to seal around these. This is a floor that has a tub up above it, and they had to cut out this OSB in order to get these fittings to fit and get them all connected in this stuff. So they put this cover over here, but that needs to be sealed around it as well. This is a junction box in an exterior wall. You have to seal around that because air will escape through those gaps around there. And then this is a junction box in a 3-story building, I think you said, Gina?
Yes.
I see red caulking, so that's fire caulking. So this is not just a separation for energy, but a smoke and fire separation. But when the sheetrock goes on here, I guarantee you it's not going to be cut perfectly around this box. So there's going to be a gap, and so that's going to have to get sealed around as well.
Let's move on and take a look at bottom plates. There's so much going right in this picture, but then there's one big, there's this big nail that missed its stud. But then there's also, we see daylight. Is seeing daylight a good thing?
No, it's not. And so, like I said, if you're pressurizing this house, there's going to be a storm of air just flying through that hole right there, that gap at the bottom. So basically, if you're inside the house and you walked up and you put your forehead against the exterior siding and look down, you're seeing daylight there, and that really needs to be caulked or have expansive foam. Now, the good things about this photo is, as I see some over here, you can see where they caulked that, so they just missed this over here. And then also between the slab and the bottom plate, they put a nice clean bead of caulk. It looks like they even may have rubbed their finger to make sure it pressed up in there really well. But that right there is definitely a fail.
And let's take a look at windows. And windows, there has to be some coordination about who's doing what.
Yes, the foam that's used around windows has to meet the window manufacturer specifications. In the early days, when they first started really emphasizing sealing around windows, they were using the wrong kind of foam. They were using a high expansive foam, and it was actually strong enough when you sprayed it between the framing and the window frame. It was strong enough to bow the frame, and then we had windows that wouldn't slide properly and things like that. So now the window manufacturer has very strict requirements on what kind of foam you're allowed to use around windows, which sort of implies that maybe it should be the window installer who's doing that and not the insulation contractor. But that's totally up to them. As long as they figure that out, as long as it's addressed early in the process, and as long as they're clear what needs to go in and who's going to do it. Now the problem with windows is the framed opening is usually substantially larger than the actual window, so there's a huge opportunity for air to escape through there. But you also have a lot of extra framing around windows, the cripple studs and the king studs and all that, and so some of those have gaps in them. And if they do have a gap, that needs to be caulked and sealed. So you see here they did a nice job. So this all looks pretty good. I see lots of caulking and lots of foam. I don't see the foam yet in between the windows, so maybe that's going to happen later.
Let's talk about round penetrations in a square house.
Yes, round pegs and square holes. That's very common. HVAC ducts are typically round, and they're going down through a square chase, and it requires a little extra work and attention on the part of the framer or whoever's job this is, and sometimes they just get lazy and they miss stuff like this. So this is air is going to really pass through here. If you look way down in there, you can actually see the first floor, and when you have vertical shafts like that, the air moves even more because of that thermal siphoning effect, and so they really need to cut a nice piece of OSB or something and patch this in and put caulk or expansive foam around it. Now over here on the right, we mentioned they did a good job. I see this foam here. They cut a nice triangle piece, but this is a B-vent that gets hot, so they're required to use this metal flashing, and the metal flashing has the round hole cut in it and the square flashing, so that's easier to cover up a square hole. But up above this, there needs to be some sort of a little dam around that to keep the insulation away from it. And here's kind of what you would see if you're looking up above that. There's framing in the way, so you have to be careful about that. Notice that they laid down a bead of latex caulk here before they put this flashing down. All right, so that all looks good. That looks like it's to be nice and airtight. And then whenever you're caulking something that's going to get hot, like a B-vent, you have to use special caulk. So this red stuff is fire caulk. So that's probably going to be the sub that's installing the fireplace is going to be the one to do that. So now that's another trade that's involved in caulking and sealing and making the house airtight. And then this is that little dam I was talking about. These are pretty hard to do well. You can see it's a pretty complex cut that they have to make in this piece of sheet metal to get it to go around there and maintain this spacing between the hot surface and this outer dam. And they have to screw it all down, staple it down, and caulk it and seal it. And actually, this doesn't have to be caulked and sealed. Sorry, this is just to keep the blown-in insulation away from that hot pipe. But that's a pretty substantial amount of work. A lot of times in older homes, you'll go up and all they do is they just push the insulation away from it, and you just have this big uninsulated spot in your ceiling.
I have to say the crafter in me looks at this as a fun crafting project. That's probably not most contractors. Let's talk a little bit about relying on the subfloor as an air barrier and when that just always gets messed up by someone.
Yes, this is, again, this is a tub where they had to cut the OSB open in order to get all this plumbing to go down through there and make those connections. They need room to do that, so they're going to have to cut a pretty big opening. And too many times I go out and I see this is just left wide open. You can just reach up in there. But to do it right, you need to cut something that fits snugly around all this little obstructions, the pipes and the square hole and everything. And then I love to see the expansive foam sprayed on there to make it a nice airtight seal.
And this is one of my favorite stories. This is we talk about Rick Chitwood a lot because he's one of our favorite people, and he was doing a blower door test on this particular house. And they'd actually prepped the dining room because they were about to paint the ceiling the next day. So they taped down a tarp for painting the ceiling the next day. And he says it really funny. They were here at the door, you know, like really concentrating on getting the air tightness around the door and getting the fan started. And then all of a sudden they turned around and saw this. Why are we using this as an example of depending upon the subfloor sheathing as an air barrier, Russ?
This is a great example of how air is just going to find a way. If you have a crack between your OSB, like over here in this picture, you see this OSB subfloor, there's seams in there, there's joints in there, and if those aren't sealed, air is going to move up through there, and it's just going to find a way. And so the air found a way around that subfloor, and now it's coming up through this hardwood floor. Hardwood floors are just pieces of wood, you know, pressed up against each other and nailed down. Those aren't designed to be airtight, so it's the subfloor is what has to be the air barrier in this case.
Let's now look from in terms of rim joists and blocking, and I'd like you to also talk about that, and I'm blanking on the word right now, but between two stories of a building, we have the floor and that the perimeter of that particular, the floor, what's that called, Russ? Help me here.
The band joists and the rim joists?
Exactly. So what are we talking here in terms of rim joists, and where there might be some exceptions to some of these requirements we're talking about?
Sure. So you have a first floor wall that's framed, and then you set your floor joists above on top of that wall, and then you put your subfloor down on top of it, and then above this they stack another wall. So you've got wall, then you've got these rim joists that are usually about 12 inches, and then your bottom wall. So you can imagine this 12-inch band all the way around the entire building on all sides going around, that sometimes they forget to insulate that. And that's a substantial amount of area that doesn't get insulated. And so one way to do it is to just cut bats. And because of the weird shape of this floor framing that's very, very common, it's called a TJI, and it's basically an I-beam made out of wood. So this top and bottom flange are wider than this center, this webbing across the center. So it makes kind of a weird shape that has to be, the insulation has to be, you know, tucked in there all nice and no gaps and no voids. If they're using a rigid insulation like up here, they have to cut this little extra piece, because if they didn't, air would just pass right through there. Over here you can see they trimmed it around there real nice, and then they even put foam over that. Now this is the one vertical surface. There's an exception to having an air barrier on both sides. So if this was a knee wall, you would have to put an air barrier on this side. But for floor joists, for band joists and rim joists, you don't have to do that. This would be fine. In some cases, they do put a rigid foam in there, but I think that's more just to make it easier to cut and trim and get it in there, and then they put a nice bead of caulk around it.
So let's take a look at cantilevered floors. This is a pretty popular feature I find at the entryway of a home, and it's maybe the master bedroom that's cantilevered over the entryway, and they have some nice lighting features, and it's like this little like cave-like feel as you're walking towards their house. What are the challenges?
Well, the challenge is trying to figure out exactly where your thermal boundary is going to be. If you come down, let's start up here on the top here, and we come down this wall, the thermal boundary is along here, but then we have a choice. Do we come across this surface to be the thermal boundary, or do we go all the way down and come across this surface? Well, either one's okay, you just have to choose. In this situation, they chose this to be the thermal boundary, and so the floor insulation has to be tucked up snug up against it. And then as you come along over here and drop down, you need a continuous air barrier all the way through. And so what happens a lot is you see this blocking here. The floor joists here are running left to right. So the big TJI floor joists are running left to right here. And so between those floor joists, they need blocking. And that blocking has to be airtight, because if it isn't, and this blocking wasn't here, you've got conditioned space over here and unconditioned space over here with no air barrier, and air can freely travel through there and carry BTUs with it. And so that's why this blocking is so important. And then the thermal boundary just follows all down the wall like this. even if it's an exterior rated light for outside, if it's in a insulated boundary, it needs to be IC and AT rated, just like if it was in the ceiling of the inside of a house.
I know that definitely surprised people in the last code cycle when that came to be. And here's our favorite tub consideration, Russ. What do we need to coordinate when it comes to tubs and showers and how we deal with our air barrier at those exterior walls?
Yeah, the big problem here is just the sequence of events. The tubs and like the big fiberglass tub shower inserts and any of those things, if they're going up against an exterior wall, they typically go in long before the insulator comes around and does their stuff and before the drywall person does their stuff. And so if that's going to get covered up, that has to be done before that tub and shower goes in. And so that's a real coordination problem. So you see the guy running a bead of caulk down here, that's great. That all needs to happen because if a tub like this is going to be installed here, once this tub goes in, there's no way to get at these walls underneath. And so you can see they actually sort of pre-sheetrocked behind there, which is great. This is what you want to see. I love seeing that bead of caulk along the bottom there. And those get missed a lot. That's a big, big problem that we run into.
Let's take a look at our next set of inspections. Now we've got our air barriers done. Oh, wait, we're not quite done with the air barrier. We're starting the insulation inspections. Why are we doing another air barrier inspection here at this point, Russ?
Well, typically they'll use blown-in ceiling insulation, and that's usually one of the last things that gets done. They have to sheetrock and everything, but this is a good opportunity to get up in the attic and really see what kind of surface you have to deal with. This may not be the case, but this is a good example of what a hardcover might look like. If this space right here were a part of the house that had lower ceilings, like an archway or something like that, and that sheetrock wasn't there, the insulation would just fall right down inside that hole. And so they put, something across to make so that when the insulation gets blown in, it makes a nice level surface that's even. It's easier to insulate. Thermodynamically, it has less surface area for heat to pass through. And this is also a good visual of sealing the top plate. That's something that gets missed a lot too, is the very top edge of the sheetrock, when it lays up against the top plate, that has to be sealed. And so on this one, they did it from above. There's other ways to do it. You can put a little foam strip across the bottom where you won't see it, but you need to be able to see it before it happens so that you can inspect it.
Now let's take a look at what's going on with insulation. Insulation's in direct contact with the ceiling. Do we have that happening on both pictures here?
Well, we have a couple issues. Let's just say it's not forbidden to use fiberglass bats in an attic, but it's really, really, really difficult to meet QII because there's so many obstructions and penetrations and things that, like this orange pipe here coming through, that's going to hold the insulation away. So remember, in order to pass QII, the insulation needs to be in full contact with the air barrier, and so in a ceiling, that's your ceiling sheetrock, and so you would have to trim around this. You'd have to cut it very closely, and then the other thing is you can't have any voids or gaps in between the bats themselves. The bats have to touch each other fully and completely, and a lot of times trusses like this truss here, if this was fiberglass bats, that truss would hold those bats apart, and there'd be a gap there, so it wouldn't pass. So it's really difficult. It's not completely out of the question, but it's really, really difficult to pass QII with bats in an attic like this. Now, here's an example. Just because they use blown-in insulation doesn't mean it's going to be done right either. You'll see this depth stick here, and let's say the target depth was 13 inches right across here, but oops, look over here. This is definitely not 13 inches. This is not a very good job of blown-in insulation. What you want to see is a nice, flat, level surface all the way across, and have all your depth sticks covered up to the right depth.
There's a funny story behind the picture on the left with this. Is Rick Chickwood again, and this is right at the attic access. And he popped his head up, and he popped down and went, "You failed." They're like, "You didn't even go in the attic. How could you fail us already?" So Yeah.
The world's fastest QII inspection. Yeah,
Exactly.
definitely.
Can lights. So we talked about how it's a penetration. Let's talk about what the issue is in terms of insulation.
Sure. The IC rating has been around for a long time. That's insulation contact or insulation covered rating. That just means that the insulation can touch the can. That's been around for a long time, but the newer certification is this AT or airtight certification, and that just means that the can has a lot less holes in it. It's more airtight, and that's very important. If you have a lot of can lights in your house, they will leak. Even the AT ones will leak a little bit, and the more you have, the harder it's going to be to pass a blower door test and things like that, and it will leak. But the other thing is sealing around the sheetrock so that you don't get this air movement around the edge, not just having the can be tight and not having any air pass through the can, but where it penetrates the sheetrock. That's very important to seal around there as well.
Let's take a look at what we're talking about in terms of seeing insulation and air barrier, all six sides. So our picture on the left, this was Bright Green Strategies, again, going out and doing an inspection and seeing this at the corner. And you could see at the lower part of, I'm going to steal your green arrow, though. Russ is going to do it for me. You'll see how there's this void. So the HERS rater could very clearly see there was no insulation in that framed corner, but as you can see, the exterior finish was already in play. What's the solution for this?
That's a tough one. If you imagine that this is 8 feet tall, how are you going to get insulation up into the top of this? You could bring out I don't know, maybe a long tube with some expansive foam and try to fill that up. Maybe you can cut a hole in the top and fill it up with loose fill cellulose or something like that, but that's going to be a tough one.
And are you now going to be suspicious of all the other corners in the building?
Absolutely.
And what do you think of my picture on the right?
That is a very common, that's what you see 90% of the times when you walk out on a job site. That's exactly what you see. And someone might say, well, this one doesn't look too bad. It's full, it's fluffy. But imagine holding a straight edge up across the edge of these studs, and what you want to see is no places where that insulation is not touching that straight edge. This over here is very common. This is unusual because normally they will put the insulation in front of the wire. In this case, they actually took the time to tuck the insulation behind the wire, but now when you put the sheetrock on there, you can see how big of a gap. And whenever you have gaps in insulation, you have air movement. Those little thermal siphons start circling around inside there and degrade the R value.
So here I'm going to show some pictures of installs that are doing pretty good and are doing pretty well in doing that all six sides. I do have some people who don't love my spray insulation picture. Why is that, Russ?
Oh, it's hard to tell, but there's a few little places here where it looks like some of the insulation fell out. You would take a straight edge and you'd hold it up there and you would see how big that is. It's not too difficult to take a little handful of that insulation and kind of pat it in there. Here's another little spot. But all in all, that looks pretty darn good. This looks down here looks really good. You can tell that when you put the sheetrock over these studs, that insulation is going to touch the back of the sheetrock. This is a really good job down here. This looks pretty good too. This is pointing out the fact that even the rim joists have to be in contact on the tops and bottoms. But remember, I said rim joists don't have to be six-sided like all other vertical surfaces do. They're the one exception.
And now let's take a look at a few more pictures here. We're seeing pictures of the delaminated being done pretty well. But on the right, they did it for one cavity but then missed it for the next. Is this pretty common to see this type of variety from one stud bay to another?
It really is, unfortunately. And like we were saying, there's so much turnover in the job that this may have been one person's last bay, and this is probably the next person's first bay to do. And so you just never know. But yeah, it's common. We call this a Friday afternoon job. They just wanted to go home and have a beer, and I can't necessarily blame them for that. But yeah, you see this all the time. Delaminating is a word that just means insulation in fiberglass bats. If you look at this edge of this bat, you'll see that it's in layers. When they manufacture it, it's layers and layers and layers. And you can just take your thumb and separate those layers, and so you can tuck half of it behind the wires like this, and then the other half just lays right over the top of it. But you want to make sure that that wire doesn't create a gap between those two parts of the insulation.
And here is, we're taking a look at our skylight well again. Avery, here's that picture that I was promising you. What's missing here, Russ?
Well, there's kind of a lot missing here. The air barrier that has to be on the attic side doesn't necessarily have to be rigid material like sheetrock or OSB. There are some flexible materials that are acceptable air barriers, but they need to be tight. They need to be straight so that they're making full contact with the insulation. And then the biggest problem you see is it just stops. There's nothing over here. So this will be, how are they going to insulate that? How are they going to make sure that it's in full contact on both sides? And so this diagram over here shows a rigid air barrier, which is a little easier to install. But this could be made to work, but this is just a sloppy job in this particular example.
So now that we've gone through our inspections, we've done our air barrier, we've done our insulation inspections, we have a few questions for you, and let's go into a check your understanding. So, which of the images below displays proper wall insulation? And I'm not even going to say for QII, just period. We didn't trick anyone here, Russ. Everyone's saying image number 1 is the proper way to do things. Thank you for no one picking number 2. Let's go on to our next question. Which of the following is the responsibility of the building inspector? The building inspector is going to provide the CF1R certificate of compliance document. The building inspector is going to schedule the HERS rater. The building inspector is going to confirm that QII is in progress at framing inspection. The building inspector is going to verify that CF2R and 3FCRs are provided for final. So there's actually a couple of right answers here. We would really like to have that HERS rater, that inspector verifying that that first air barrier, oh wait, at framing, there isn't an air barrier inspection at framing, is there, Russ?
That's a
little early. It would be
early,
great
yeah.
if early on in the construction practice that inspectors like, hey, I haven't seen any HERS CF3Rs at all, and you guys better have someone soon before I start seeing insulation installed, and help that construction team be successful with QII. But you definitely they're going to verify the CF2R and 3R provided at final, and they're going to belong to the building owner. Excellent. Let's move on to our last challenge, in which we're going to challenge Russ to go through our project set of drawings. This is where you might want to walk through with us. You have it as a download. And he's going to I keep forgetting we're going to do this first. We're going to talk about what's changing for 2019 in terms of HERS verification practices. Russ, what's changing?
Well, the good news is the actual protocols and the requirements of how to pass QII are not changing very much at all. They've cleaned up the language a little bit. They've clarified some things. They've plugged some loopholes that have been in there in the past. But the main thing they're doing during the big change is in the forms. They're really cleaning up the forms. So you'll see in the 2016, there's the EMV 21, 22, 23, and 24, both the 2R and the 3R. Well, they're getting rid of the 23 and the 24. They're consolidating it all into the 21 and 22. Plus, they're putting an itemized checklist on the 22, which they had for a while, and then they took away for the 2013 code, or the 2016 code. And now it's coming back, which is good. I think it's really important for the installers to have that same checklist that the HERS raters are using. So they're getting rid of some forms. They're consolidating it. They've cleaned up the language, and I'm really pleased with the way the new forms are turning out.
But now we're going to challenge Russ with doing the first run of going through these drawings with the entire design team there. Russ, walk us through how you would do that type of meeting.
These are great. I used to love doing these. They used to call them value engineering meetings. Now they call them kickoff meetings or trade meetings. But they would send out a sample set of plans or preliminary set of plans to all the trades, and they'd all just meet in a room and start talking about stuff. And they'd kind of go around the table, and each person would identify stuff. So if I was a HERS rater and somebody sent me this set of plans. Um, the elevations have some clues in it that you want to look at. So one thing I would really look at is I'd say, okay, this is a one-story house, but I see this gable window up here. What's going on with that? Is that a fake window just for looks, or is it actually, can you look out it from the inside? And if so, how are we going to sheetrock around that and make, what's the air barrier, what's the external thermal boundary going to be around that? The other thing that jumps out at me is, you know, construction these days, when you have a roof like this, is usually these big triangle-shaped trusses. So this is going to be a big truss right here, and this particular truss is going to create an attic, but you'll notice that the attic goes from conditioned space, and then right here it goes out over a porch. So somewhere in this attic, there's a boundary between where the insulation is above conditioned space and where it is above unconditioned space. How are they going to deal with that? This is a garage over here, so you've got an attic above the garage, and it's going to look like it's going to continue into the attic of the house. So same thing, we have a situation where you've got attic over conditioned space and unconditioned space. How is that going to be dealt with? How are they going to do the wall between the house and the garage? They're going to have to make sure it gets sealed up and things like that. So there's a few clues on the elevations, but the big one that you have to look at very closely is the floor plans. So here's the garage over here, so we don't have to worry too much about that, except like I was saying, in the attic, the insulation is going to be above this part of the house, but not above here. How are they going to separate that? But what I really look for when I see a floor plan like this is the first thing I clue in on is, what does the ceiling look like? Is the ceiling flat? Is it vaulted? And if it's vaulted, what's next to it? And so looking at this floor plan, I see back here in the master bedroom, there's a ridge here, and it says vaulted. So there's a triangle-shaped roof that slopes down to the left and to the right, and then these rooms are flat. So there's going to be a triangle knee wall right along here, and we're going to have to make sure that gets called out in the plans and that they put a detail that shows air barrier on both sides of that wall. And then the same thing here. Look, there's a ridge running left to right across this entire living room and kitchen, and these rooms are flat, so there's going to be a triangle-shaped knee wall over here. Okay, energy consultants are pretty good at seeing those types of things because those have to be modeled. So it certainly wouldn't hurt to have the energy consultant point those out as well. But in a kickoff meeting, a HERS rater would be, you know, be a good person to have identified those types of things. And then look right here in this dining room, you have what's called a coffered ceiling. So this shape here in the middle, the ceiling is higher than it is on this part over here, so that creates a little wall. This little dotted line here is actually a vertical wall that's going to have to be addressed. And the only exception to vertical walls not having air barrier on both sides is a rim joist, which this house doesn't have because it's a one-story house. So that little wall is going to have to get some special treatment. Okay, I see an attic access over here that has to be sealed. You have to have ceiling around attic access, weather stripping, I should say. But then the other thing, moving down a level, is all the tubs that are adjacent to an exterior wall. So here's one here, and so the wall behind that tub needs to get insulated and have an air barrier, so probably a sheetrock before that tub goes in. And then over here is a shower.
That's going to have to happen for that fireplace too, right?
Oh, thank you, yes. So right here too, you see this fireplace has some exterior wall. And then also up above in the attic, this fireplace is going to have blocking around here so the insulation doesn't fall down inside there. So yeah, a lot of things going on here. And then remember I was talking about this porch, this front porch. So there's actually attic above this front porch and attic above the house. And you've got this kind of a strange shaped wall here. Actually, it starts way over here. So it runs all along here, and then out this bay window like that. Now, how are they going to keep the insulation inside here from falling over onto this uninsulated ceiling over here? Are they going to put a dam in here? Are they going to put a wall in there? What are they going to do? So that's an important detail that needs to be called out in the plans.
Let's take a look at their sections. Is there anything that is concerning here as you're looking at the sections?
The sections show a couple things. One is that little coffered ceiling. So here's those little tiny walls I was talking about. Those walls have to be insulated, and they have to have an air barrier on both sides of them. Unless, I would say, if these walls were only, say, 8 or 10 inches tall, and you were blowing in, 14 inches of insulation, they're completely covered, so I wouldn't worry too much about them. But if the insulation is stepped, like it is right here, you can barely see it, those little walls would have to have a sheetrock on both sides or an air barrier. And then here's that triangle knee wall I was talking about. So this is a vaulted ceiling. At some point past the page, there's going to be a wall, a knee wall, that has to be insulated and has to have sheetrock on both sides of it.
Let's take a look at the details. And there's been a lot of work that was put in putting together details that we thought would help you the most. What are we seeing here at the floor?
So this, the floor is the air barrier, the subfloor. And so as we mentioned, the seams of the OSB needs to be sealed and all that, but the insulation needs to be in full contact, so there can be no gaps. This insulation has to be held up somehow so that it doesn't sag down and leave a gap in this floor.
And now let's take a look at, our header. Now we did talk about potentially we have double insulation going on, but we kind of actually wanted to show you a couple of different ways of doing it. And I wanted to clarify here, what happens if they did the header and they didn't insulate the inside face, but they were going to use that R5 rigid insulation on the outside? Is that a fail, or is it meeting the intent of the insulated header?
It meets the intent. This R5 is actually insulating the header, and it's meeting the requirement for a 2x6 framing. And it breaks that thermal gap, so there's no wood that the heat can pass through all the way to the inside of the house.
And let's take a look at what we're seeing here in our vented attic space.
Yeah, one of the big things about QII and just doing insulation really well is baffling the insulation away from any venting. Attic venting is very important. A lot of houses have cooling problems because their attic vents get blocked off or they're inadequate, and that heat gets trapped in the ceiling. Even at night when it's cool outside, your attic can still be really hot and make your house feel hot. So it's very important to baffle the insulation so that air can pass freely and get up into the attic. But now with high performance attic, we're also putting insulation under the roof deck, and that's another potential place where it can block the baffles right here. So that baffling is very important. You'll see here this calls out netting. So the netting is there to keep the insulation from, to hold it up against the underside of the roof deck, but also to allow air to pass freely up into the attic.
And here, this is at that bedroom where it's, gosh dang it, I don't know why that's not sticking. It's a vaulted ceiling, but it actually has a vented attic. So it's not a cathedral ceiling. The baffling is a little bit even more challenging in this case, correct?
It is. This is what we call a scissor truss. And so, what it does is, because this is not a flat ceiling, it's raised up. So what it does is it makes the surface area where this insulation could potentially interfere with the baffling that much longer. So you can see this baffle needs to go from the E-vent all the way past all this insulation, and then the air needs to dodge that insulation that's up against the roof deck. And you'll see it says a minimum 1-inch air gap here. That's very difficult to do when you've got big floppy pieces of fiberglass bat and maybe blown in insulation on the bottom. Real care needs to be taken to make sure that air can get through there.
And we've already seen how they've dealt with their attic knee walls. We've discussed how this is a really good detail supporting what's going on. On this project, they decided to do more of an advanced framing to be able to have non-blind corners, as I like to say. And they even engaged that high, oh gosh, I just said it, alternative framing method for the wall intersections. I've obviously not had enough caffeine today. And then this is what we're seeing that's happening at the porch. Is this making you relatively more comfortable about the porch situation?
This is the better way to do it. And what they're doing is they're essentially separating the attic that's over conditioned space from the attic that's over the porch. by putting an actual wall, like an OSB wall, in between here. And because they're doing that, air can't pass between these two attics, which means they can stop this insulation right here. If the alternative would be to just have a dam that comes up just as high as the insulation, and then air could pass over the top of it. If they did that, then this insulation along the roof decking would have to come all the way down to the very bottom, because the sun is going to hit this roof, it's going to heat up, and that heat will come in here, and if this wall wasn't there, it would just come right up into this attic and not do much good. So this is the better way to do it, because you're really separating the two attic spaces and providing a real nice definition there.
Okay, so that's to get a feeling of how that particular talk would go. We're going to start wrapping things up quickly in our last minute with you. Our next decoding talk that will be coming up, we're going to talk about healthcare. Occupancy I-1 and I-2 are introduced to Title 24 Part 6 for the very first time since the Energy Code started in 1978. We're also going to do a rerun of our decoding talk on rebuilding after a natural disaster because of due to popular demand. And Russ already talked a little bit about the training provided to building departments regarding the project status report. Anyone, though, can reach out to you about this training, can't they, Russ?
Yes. One of the biggest surprises to me that I found doing a lot of building department training is how few of them use this tool. The HERS registry, both CalCERTS and CHEERS, is an amazing tool. Building departments could go paperless on all the Energy Commission forms, the compliance documents, if they wanted to, and just use the registry as a tool to to keep track of everything. And the project status report is the main tool that building departments use, with the green dots and the red dots. And we're more than happy to come out and train you how to use that.
There's also a lot of information on the DOE website. I go here over and over, including CAD details of a lot of the building features that we've talked about. Also, do check into insulation manufacturers, provide a lot of CAD details to their specific products that I find invaluable. We have so much more on our website that helps support this particular topic. But let's start talking about what we'll do for you after today. We're going to automatically send a certificate of participation to everyone who attended to the very end. This will automatically go out within a few weeks. Give us a couple of weeks. Takes us time to wrap things up, to the email you used for registration. If you attended as a group, please send in the names and emails of everyone who was there so that everyone can get their certificate of participation. And you can get a copy of all of these slides if you take our survey. Our survey is so very important because it shows the CPUC how we're using your ratepayer funds and how you feel about it all. So please, we're going to ask you more than once to take the survey. You only need to take it once. We'll ask you at least 3 times, but only take it once, and that's how you can say you want a copy of the slides. You have all of our contact information here for both Russ and myself. Catherine and her team have been the technical support to this particular, all of our decoding talks. Daryl's actually BPI. He's the guru behind the curtain with us, and he's you should see all the chat that goes on in the background of all these things that he wants to add to the conversation. The CEC hotline, our recommendation for them is email them. It's really nice to get things in writing. Joe Marver is the manager for the Decoding Talk series through PG&E. If you have any questions or concerns, do feel free to reach out to her directly. Thank you, everyone, for being here. Daryl, did we not take care of any questions? Did we take care of all the questions? Does anyone have any that we haven't, that you didn't ask out loud yet, that you'd like us to answer?
Gina, I have to ask, how do you answer questions while you're talking? That just blows my mind.
It's called having children and being female.
You're typing answers while you're talking. That's amazing.
Well, I'm also, being the music major, piano being my instrument, I can type and use my fingers quite easily while thinking at the same time.
That explains
I have some pretty scary skills when it comes to that. It doesn't look like we have any more questions that we haven't answered. I want to wish all of you a great rest of your Tuesday. Russ, Daryl, I'll see you guys in the morning, and have a great rest of your Tuesday.